All right, welcome to our lesson on arithmetic sequences. Let's get started. So let's talk about a few vocabulary terms as we get started talking about arithmetic sequences. Go ahead and grab your notes, pause the recording at any time so you can write this down. First off, an arithmetic sequence is a sequence in which the difference between each consecutive term is constant. Okay, so an arithmetic sequence is a sequence in which the difference, meaning subtraction, between each consecutive term is constant. When we say consecutive, we mean one after the other, after the other, after the other. 1, 2, 3, 4, 5, those are consecutive numbers because they're going in order. The common difference, D, is the constant difference between each term. All right, the common difference, D, is a constant difference between each term. An arithmetic sequence can be written in recursive form and explicit form. And now we're going to share with you what that looks like. So it can be written in recursive form or explicit form. The recursive formula for an arithmetic sequence defines each term in the sequence based on the preceding term. So in a recursive formula, you need to know the first term or the preceding term in order to figure it out. It requires specifying the first term and a rule that relates to any term that comes directly before it. So A sub n equals A sub n minus 1, that represents previous, plus D, and then you have the colon, and then A sub 1 equals the first term. All right, so this is the formula. Now this, yay for you guys, is actually on the formula sheet. Okay, so A sub n is kind of like your output. A sub n is your output or your nth term, equals A sub n minus 1. All of this is a notation, and all of that means previous term, plus D, which is a common difference. And then A sub 1 is your first term. That's a recursive formula. In the explicit formula, also known as the nth term formula, provides a direct way to calculate any term in the sequence without needing to calculate all the previous terms. And this is the nth term formula. A sub n, which again is your output, kind of like your y. A sub n equals A sub 1, which is your first term, plus D, parentheses, n minus 1. N is your nth term. Okay, so if you're looking at the first term, the second term, the third term, that's what you put in here for n. Okay? Write that down. You need to know what they represent. Now, they'll give you the formula, but they won't say what A sub n represents, what A sub 1 represents, and what D represents. So you need to make sure you memorize that. All right, which of these sequences are arithmetic? That is a question. Which one of these sequences are arithmetic? You've got number 1, 6, 10, 14, 18, 22. Number 2, 3.3, 3.9, 4.5, 5.7, 6.9. And then you have number 3, 17, 9, 1, negative 7, negative 15. All right, so let's take a look at them. In order to figure out if it's arithmetic, we need to see if there's a constant difference. So what I'm going to do, I'm going to say 22 minus 18. Okay, so 22 minus 18, you get your calculator out. You can say, and just put it in there. And I'm just going to go ahead and put it in my calculator so we can just calculate that real quick. All right, so 22 minus 18 gives us 4. Okay, so that's 4 right here. All right, how about 18 minus 14? Well, we know that 18 minus 14 is also 4. And then 14 minus 10 is also 4. And then 10 minus 6 is also 4. So there is a common difference. Our common difference is D equals 4. This one is arithmetic. Yes, that is an arithmetic sequence. Let's take a look at the other one. And notice when I do the subtraction, I go from the back to the front so that you remember it's y2 minus y1, or, 6.9 minus 5.7. I get 1.2. So that's a positive 1.2. Then I'm going to say 5.7. 5.7 minus 4.5. Oops, I put a plus. That's supposed to be a minus. All right, let me just go ahead and say 4.5 minus 3.9. 4.5 minus 3.9. 4.5 minus 3.9. Uh-oh. And then 3.9 minus 3.3. Okay. So 5.7 minus 4.5, let me make, was 1.2. But then when I did this, it was 0.6. And when I did this as well, it was also 0.6. So it changed. So this is not arithmetic because it has to be the same for all the digits. So always try it out for all of them. So this is not arithmetic. It is so hard writing on this thing. So this is not arithmetic. All right, let's take a look at number 3. Use a different color here. All right, and again, I'm going to go from the back. Let's just go ahead and refresh. So I'm going to say negative 15. So if you're not good with your negative numbers, go ahead and use your calculator. It's, oops. Negative 15 minus negative 7. So you're going to have two negatives there. Then we have negative 7 minus 1. Then we have 1 minus 9. And then we have 9 minus 17. Okay, and all of them are negative 8. Okay, so from here to here, minus 8. 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 So yes, my common difference is a negative 8. Yes, it is arithmetic. Okay. Now notice when I'm subtracting, I'm going from the back because I like to do y2 minus y1. That's the rule. So it's easy to make sure you remember y2 minus y1, y2 minus y1, the second term minus the first, and what have you. So the first one and the last one are arithmetic because they have a common difference. All right, let's take a look at this last one here. Got my calculator. I'm going to say, let's close all that out. I'm going to say 112 minus 56. I'm going to say 56 minus 20 minus 28. Oop, I can already tell. 28 minus 14. We already know this is not arithmetic. And then 14 minus 7. We already know that is not arithmetic. So we can just say not for this last one because it doesn't have the same common difference. That's 7. That's 14. Okay, that was 28. So we already know. Okay. Find the common difference in the next 3 terms of the arithmetic sequences. So go ahead and pause the video, see if you can figure that out. All right, welcome back. So we're going to see, first we need to figure out what the common difference is. So I'm going to say 79 minus 66. Calculate that out. I'm going to use my calculator to help me work smarter, not harder. Okay, so let's do this. So 79 minus 66. I'm going to say 66 minus 53 because we want to make sure it is an arithmetic sequence. 53 minus 40, and then 40 minus 27. All right, so my common difference here is 13. So to find the next 3 terms, I'm going to take the last term that I see here, which is 79. I'm going to say 79 plus 13. I'm going to get an answer. That's going to be 92. Then I'm going to say 92 plus 13. I get an answer. It's 105. 105 plus 13. Make sure I check my math. So 92, 105, 118. 92, 105, 118. So if you didn't know how to do the first one, you didn't know how to do it, you wanted to see me do it, go ahead and try the others on your own. Okay, let's do the next set. So we have -5. We're going to start from the back. -5 minus -2. It's going to be two minuses here. -5 minus -2. Then it's going to be -2 minus 1. Then 1 minus 4. And then 4 minus 7. All right, 4, not 5. That's a slip of the tongue. 4 minus 7. So again, I'm going through and I'm subtracting all of these, right? Making sure it's a common difference. And I get -3. Okay, so to find my next three terms, I'm going to take that last term there, which was -5. I'm going to say -5 minus 3. And I get -8. Then I'm going to say -8 minus 3. Then I'm going to say -11 minus 3. So I have -8, -11, -14. -8, -11, -14. All right, let's take a look at the next one. Oops, get my calculator. Clear it out. Might be easier to just do that. All right, so I'm going to say 11.5 minus 9. Okay, 9 minus 6.5. Okay, 6.5 minus 4 is 2.5, and then 4 minus 1.5. All right, it is 2.5 either way. Each way, it's 2.5, right? And so my common difference is 2.5, a positive 2.5. All right, so that means I'm going to add 2.5 to 11.5 to get my next term and find the other terms that way. So 11.5 plus 2.5, I get 14. I'm going to say 14 plus 2.5. I get 16.5, and then 16.5 plus 2.5. Make sure I check my math. 14, 16.5, 19. 14, 16.5, and then 19. All right, now for this last one, we've got fractions. Don't get scared of the fractions. You've got a calculator that you can use. All right, so let's go ahead and reset that. I'm going to do the same thing. I'm going to say 11 divided, oops, that's not 11. 11 divided by 6. That's how I got my fraction. Then I'm going to say minus 3 divided by 2. I get that answer. Don't worry, I know it's a decimal. You see how you have this fraction bar, right? This little thing that popped up over here? Now you can see it as a fraction. Okay. Now I'm going to say 3 divided by 2. Get out of that denominator. Minus 7 divided by 6. Again, I can turn that into a fraction. Then I'm going to say 7 divided by 6. Get out of that denominator. Minus 5 divided by 6. Oops, 6. Right? And I click on this right here so I could get the fraction. And then 5 divided by 6. 5 divided by 6. Get out of that denominator. Minus 1 divided by 2. And there you have it. So our common difference here is 1/3. So even though it gives it to you as a decimal, you can cover over this and get the fraction. So we get 1/3 is a common difference. So that means I'm going to say 11/6 plus 1/3. And that's how you make it accurate. So 11 divided by 6. Okay, then plus 1 divided by 3. Going to give it to you as a decimal. Click here so you could get the fraction 13/6. Okay. Then I'm going to say 13 over 6 divided by 6. And I'm going to say plus 1 divided by 3. Get that answer. And that's going to make it a fraction, 5 over 2. And then finally, I'm going to say 5 over 2 plus 1/3. So 5 divided by 2, and then plus 1 divided by 3. Okay, and click there so I can get the fraction, 17 over 6. So your calculator is truly your best friend, y'all. And this is how you find the common difference in the next 3 terms of the arithmetic sequence. All right. Now, how about write the recursive formula of an arithmetic sequence? So here's a recursive formula, a sub n equals a sub n minus 1 plus d. Now this, the equal sign and this do not change. They stay the same. The only thing that changes is your d and whatever your a sub 1 here is. So in this case, a sub 1 is our first term. Our first term is 6. Our common difference, this is going up by 4 plus 4. When I subtract them, so my common difference is 4. So my formula, a sub n does not change, is equal to a sub n minus 1. And then I'm going to say plus 4. And then a sub 1 is equal to 6. That's it. Now go ahead and try writing the recursive formula for this one down here. All right. A sub 1, my first term is 17. That's the first term, 17. My common difference, let me go ahead and get my calculator out so I can figure that part. So I'm going to do negative 15 minus negative 7, negative 7 minus 1. All right, so our common difference is negative 8. So my recursive formula is a sub n equals a sub n minus 1. That does not change. That means previous term. And then I'm going to say minus 8 for the common difference. And a sub 1 is 17. Just like that. That's it. So again, the a sub n equals a sub n minus 1 does not change. Remember, that's a sub n minus 1 representing the previous term. That's the notation. All of that means previous term. This right here. All of that means previous term. And then plus d. D is what changes. What's your common difference? All right, now the explicit form is a little more different. It is a little more difficult, could be. A sub n equals a sub 1 plus d parentheses n minus 1. So a sub 1 is 6. That's our first term. Our common difference here was 4. Okay, so the same sequence, the first sequence. So a sub n is going to be equal to 6 plus our common difference, which is 4 parentheses n minus 1. That's it. That's the explicit form. Now, sometimes they might simplify the explicit form by distributing the 4 and all of that. So you might see that sometimes, but this is the explicit form. And then for the other one, our a sub 1 is 17. Our d is minus 8. So I'm going to say a sub 1, which is 17, plus d. I'm using this formula up here in case you forgot, which is negative 8, parentheses, n minus 1. Okay, so in other words, I can say 17 minus 8, parentheses, n minus 1. And that's the explicit form. Now, if you don't see it written like this, that means they simplify it. They simplified it. So let me show you how you would simplify your answer. So here, if you're simplifying, you would distribute the negative 8 to the n and to the negative 1. So you get 17 minus 8n plus 8, right? Negative times negative is a positive. Then I have 17 and I have 8. So I'd say 17 plus 8. And what's 17 plus 8? Grab your calculator. And 17 plus 8 is 25. So that would be negative 8n plus 25. So sometimes you might see it simplified all the way down. And all you're doing is just simplify, and that's also an explicit form. All right. Now it's your turn to try it out and see how you can do. Go ahead and ask questions. Let your teacher know if you have any questions.